Okay, now coming to the, so this is a subject name, that is flat. So what is the meaning of flat? It is mean abbreviation formal languages and automata theory. Okay, so the name you have to understand. When you complete all the units, then only you are able to understand the meaning of what is the language and then what is the automata theory, all those things. Okay, now coming to the some textbooks, they may give simply 80. Okay, so 80 means nothing but a automata theory. Okay, sometimes they make you TOC means theory of computation. These are the subject names. So they may call flat automata theory or theory of computation. So this is fully problematic subject. This is not a theoretical subject. Coming to the we have to know some terminologies in this subject. Okay, so first one is the symbol. So this is a theory. Actually, this definitions you have to understand while I will take a problems. So a symbol is the basic building block. Okay, so we have to use the symbols. Okay, the symbols we have to use to build some basic building blocks. Hmm. A symbol can be, it may be small a, it may be small b, small c, small d, some, okay, some a to small z, capital A to capital Z, 0 to 9. So you may take hash. Okay, you may take dollar. Okay, you may take at the rate. So these are also symbols. You may use that symbols also. You may use that also as a symbols. Okay, that is called a symbol. Okay, that's what I told. This you have to understand when you will take a problems. What is the meaning of that symbol? All those things. Now coming, this is introduction part to the theory of computation. First you have to know these terminologies, then only you are able to solve the problems on the in this subject. Next one is a alphabet. What is the alphabet? From a symbol we can form a alphabet. Alphabet is nothing but using sigma. Okay, sigma. Now what is sigma? Sigma means nothing but input symbols. Now tell me, sigma is the alphabet. What are the input symbols? So A comma B are the input symbols. So in my example, in my problem, I am taking the sigma equal to A comma B. These are not fixed. You may take any number of input symbols. Okay. So here what is sigma? Sigma equal to A comma B comma C. Now what is sigma here? Sigma equal to 0 comma 1 comma 2. Okay. So it means using a symbols, I am able to build. I am able to. These symbols are used to form the alphabet. That is sigma equal to A comma B. So not only two symbols. For example, you may take sigma equal to, you may take single, that is also valid. Okay, not only two, not only three. You may take single sigma, sigma equal to small a. Okay. Now string. String is a what? Okay, using alphabets, so I am able to form a string. See, are you understanding? So using a symbol, I am forming a alphabet. Okay, using alphabet, I am forming a string. See, from a alphabet we can form a string. So string is the sequence of these symbols. What is symbols? Okay, so a comma b comma 0 comma 1, so like that. Okay, now I am taking some strings. So I am taking a. So a is a string of length 1. For example, you take a string a. Length equal to what? Length means simply you count the number of symbols, which is equal to 1. So the terminology is different from the programming languages. It is purely different in the subject. Okay. So B is a string. Okay. A is a string. A B B C A B A. Okay. So what is the length of a string here? Simply count the number of input symbols 1, 2, which is equal to 2. Okay, I am taking a one more string a b a. What is the count equal to? Count is nothing but a length of a string equal to 3. Now in this, what is sigma? In this example, what is sigma? Sigma equal to a comma b. That is what it means. Using this alphabet, I am forming a string. Okay, again, what is alphabet? Nothing but a input symbols, mean symbols. So what is symbols? Symbols may be any of these. That is what some symbol. That is what symbol. Okay, symbol, alphabet, and then string. Okay, now coming to the language. A language is a collection of strings. So this is what hierarchy. Okay, So from a symbol, I am forming a alphabet. From a alphabet, I am forming a string. So from a string, what I am forming? I am forming a language. A language is a collection of strings in theory of computation. Okay, I'm taking some examples. So L1, set of all strings of length equal to 2 on sigma equal to a comma b. It means I have to form the some strings sigma equal to a comma b. What is the condition they have given? They have given condition as a length is exactly 2. Okay, it means if you take a any string, if you take a any string length equal to how much? Length equal to 2. So length equal to, so how to find the length? Very simple, you take like this and count the number of input symbols 1 2 which is equal to 2. If you take ba, how many I'm having? 1 2, that is what count. Okay, so now language equal to what? Collection of strings. That is the definition. So a language is a collection of strings in the theory of computation. Okay, or flat or a automata theory. That is what. Now I am taking a one more example. So there is a one word is there, finite language. What is a finite language? When you are able to count the number of strings in a language, that is called finite language. It means I am taking this language. What is the language name? It is L1. So how many strings I am having? 1 2 3 4. I am having a finite number of strings. It means you are able to count the number of strings. Okay, that is called a finite language. Now take a one more example. Now L2 equal to set of all strings where each string start with A. See, that one thing you have to make a note. There will give a one condition will be there. Okay, there is one condition will be there. What is the condition they have given? If you take a language, in that language, each string it must and should start with A. Now see, now can you tell what is sigma here? Sigma equal to A comma B. That is sigma here. Okay, so you take a 3s, aab, abb. So what is sigma here? Sigma equal to A comma B. Okay, now can you tell this is a what type of language? It is finite language or infinite language? It is infinite language. Why? Because I am unable to count the number of strings. So 1 2 3 4 5. So for example, can you tell one more some more strings starting with a, like a a b a b a. So this is a string starting with a. So take one more string, for example a b b a. This is a string starting with a. Like this you are able to form any number of strings. So what is the language name? This is the infinite language. Okay, that is what infinite language. This is a finite language, this is the infinite language. That is about the languages. Now coming to the, so these things you have to know. See, in depth there is a lot of information is there. So meanwhile we'll discuss all the information. Okay, these are the basic terminologies in the flat subject or a theory of computation or a automated theory. One is what? One is symbol, alphabet, string, and then language. Okay, so these words we are going to repeatedly we are going to use in the subject. Okay, next one. Now coming to in the subject, basically when you see the syllabus of the subject, it is looking very huge syllabus. It is a very huge syllabus actually. So when you summarize, okay, when you brief, okay, so in this we are having only three concepts. So in the subject we are having only mainly three core concepts. Okay, so whatever the sub concepts, so they will fall in the grammars, they may fall in the languages, they may fall in the automata or a mission or acceptors. Okay, so what I'm telling, any subtopic, okay, any subtopic, any subtopic, they may fall in any of these three concepts. One is what? One is the grammars, languages, and then automata. Okay, automata, machine, or acceptors. So what is the three core concepts? So one is grammars. Okay, one is the grammars. Second one what? Languages. Third one is the automata, mission, or a acceptor. So generally the basic word we have to use, it is a mission or a acceptor. Okay, so automata also a mission. Okay, I will tell meanwhile what is the meaning of automata. So these are the three main core concepts in the flat subject or a theory of computation. Okay, now come to the, so what is the grammars? Now coming to the grammars, we are having the four types of grammars. Okay, I'll tell when you go in depth. So we'll discuss what is the grammar, all those things. So grammars, we are having four types of grammars. One is regular grammar, context free grammar, context sensitive grammar, unrestricted grammar. These are main types of grammars. So regular grammar, context free grammar, context sensitive grammar, unrestricted grammar. Okay, next, now coming to the types of languages. Now coming to the types of languages, here we are having four types of languages, four types of missions. So what is the four types of languages? Regular language, context-free language, context-sensitive language, and then recursive language, and then recursive enumerable language. See, simply I am listing this is a syllabus. Okay, so any subtopic will fall in any of these three main core concepts. That's I want to tell. Okay, even though the syllabus is very huge, these are the brief summary of the syllabus. Okay, third one is what? Acceptors or missions. Okay, so this is the missions. So how many I am having? Finite automata, push down automata, linear bounded automata, and then Turing mission. So one is what? One is grammars, second one is the languages, third one is the mission or acceptors. So in this, how many I am having? I am having a four types of grammars, four types of languages, four types of missions. So this is the main core concept of the automata theory or a plant. Now coming to the, okay, directly I will take a problems. Okay, so in this video I am discussing only introduction about the subject. Next one, first we will discuss about the finite automata. Okay, finite, see you have to think about the name. Finite means what? It is finite amount of memory, finite amount of memory. Okay, I'll take a diagram meanwhile. So let's go with the basics. So finite automata, what I'm taking, I am discussing about the first one. Okay, finite automata. Now finite automata is a mission, it will accept regular language. Are understanding? So it means what? So now I'm writing here, so regular language is accepting the, is accepted by the, what is the mission name? Mission name is the finite automata. This is very important. Okay, it means the regular languages, okay, will accept by the finite automata. Okay, now coming to the, what is, first of all, finite automata is a mission. Actually, what is a acceptor? That is very important point. Are automata. So what is a automata or what is a, acceptor? It means I am going to build one automata mission for a given language. Okay, see, using for this language I am building this model. Okay, then what I'm telling, what I'm asking for this model I am giving one input. What is input? That is a string. Okay, string. So then what is acceptor? It is going to tell yes or no. It means the string is present in the language or not. Okay, that is one idea. What is one more idea? So I am giving two inputs. Okay, one is language, second one is a string. Okay, now what is the purpose of acceptor? Okay, this finite automata will search, okay, or make a decision this string is present in the language or not. That is what? Yes or no. If it is present, it will say yes. If it is not present, it say no. Okay, what I said first point, for this language I have built this finite automata. Okay, okay, now what is a language? It is a collection of strings. Now again, what I'm saying, for this finite automata I am giving one language. It may be some, it may be one language, it may be any new language. Okay, or same language. Okay, I mean, whatever the language, okay, for what language I have built, this is the language. Okay, so for this language I have built this mission. Then what I am asking, I am asking this mission, this string is present in this language. It is going to search in this language and say yes or no. That is called acceptor. That is called mission. Okay, 2 points you have to understand. Okay, one is what? I am building the mission for this language using this language. Again, what I'm giving, I am giving input as a language, string as a input. So this is going to check whether the string is present in the language or not. If it is yes, yes. If it is no, no. That is called acceptor or a mission. Now what is the language here? It is the regular language that you have to make observation. See here, we have to build a finite automata for L. Here L means regular language where we give input as a string. Okay, actually that is the main concept. The finite automata will say yes or no. It means what? The string is present in the language or not. That is called acceptor. Okay, now coming to the types of finite automata. So what is the types of finite automata? So with output and then without output. So, see, simply first to go with the briefly, then we will discuss in depth. Okay. So how many types of finite automata? One is with output. Second one what? Without output. Now coming to the with output, how many I am having? More emission, mill emission. Without output, how many I am having? I am having DFA, NFA, NFA null. Okay. So with output means what? They are going to print output Mure and then Mealy. Okay, what is a without output? They do not print any output onto the screen. That is called without output. Okay, first we will discuss the problems on the DFA. And one more thing, this is completely a problematic subject that you have to understand. What is acceptor? I am telling one more time. Okay, I am writing here. First they will give one language. Okay, they will give one language. For this language I have to build a one mission. That is called a finite automata. Now what you are saying, I am giving a string for this. It says yes or no. The string is present in the language or not. Yes or no. That is called acceptor. That is called a automata mission. It says automatically checks and say yes or no. That is called automata or a mission or a acceptor. Okay, so in the next video we'll take some problems on the DFA. What is a DFA? What are the properties of a DFA? Everything we'll see in the next video. Okay, so this is introduction to the automata theory or a theory of computation or a flat subject.